I am coming back here to finish up our order of operations. I have a couple more examples that I want to cover. And again, I'm going to show some additional tools that you can use in order to solve some of these. Here I'm going to take a look. I have no parentheses. I have no exponents. Right? Now I'm going to go ahead and I'm just going to start with my multiplication division going from left to right at the same time. So my 16 divided by a 4 is going to give me a 4 times 4 divided by 2, and then I'm going to multiply by 256. Oops, 256. Smush it all together there. So now I've got my 4 times 4 is 16. 16 divided by 2 times 256. I am going to go from there. I go 16 divided by 2 is going to get me an 8 times 256. So I'm going to show you how I think about it, and then I'm going to show you another way, that lattice multiplication. And again, don't stress too much about understanding the lattice multiplication in this video. I'm going to do a separate video altogether about lattice multiplication. So here's how I think about this. I know that 250 is going to be really easy to deal with. So I have 8 times 250. And then I'm going to add, because I still have this 6 that I have to deal with. I'm having 8 times the 6. So since I have 8 times 250, well, 4 times 250 would be 1,000, so that's going to be 2,000. And then 8 times 6 is going to be 48. So I have 2,048. And again, I'm going to show you how I do that with lattice multiplication. All right, I have my 2, 5, 6, and I'm going to multiply that by 8. So here I'm going to have 6 times 8 is 48, and 5 times 8 is 40, and 2 times 8 is 16. So here I'm going to go along the diagonal, so I've got an 8, and then 4 plus 0 is going to be a 4. And a 6 plus 4 is going to be a 10, so I'm going to put my 0 there and plus 1 up here. And that gives me a 2. So my answer, again, is 2,048. All right. Let's take a look here. So I have a bunch of groupings. First of all, I have a grouping, it's a numerator, and I have a denominator, and then I have a grouping inside the numerator. So I'm going to rewrite this to be 10 divided by 2 plus 9 times 4. And because these are two separate groupings, I do not have to do this next. I can do all of the numerator and then come back and do all of the denominator. Personally, I generally like to do that unless I can see that there might be a trick to it. And I'll show you a case where that's also the fact. So I've got 2 to the 5th plus 3 squared. So I'm going to have 5 plus 9 times 4 is going to get me 36. And that's going to still get me my 2 to the 5th plus 3 squared. So then this is going to give me 41 in the numerator, and then I still have my 2 to the 5th plus 3 squared. So 41. And then I've got my 2 to the 5th, and that's going to be 2 times 2 times 2 times 2 times 2. So that's actually 32. And that's not, maybe isn't intuitively obvious when you look at this, but if you were to go 2 times 2 is 4, and another 2 times 2 is 4, that gives you 16, and then you have one more 2 to deal with. That would get you your 32. And then 3 squared is going to get me a 9. So I have a 41 over a 41. So my answer is 1. All right, so this one's kind of interesting because it has all kinds of negative exponents, and it's got a division in there, and so I'm going to rewrite this so that I've got everything so that it's got a positive exponent on it. So I've got 3 to the 12th times 1 over 3 to the 4th divided by 3 to the 3rd times 1 over 3. And I'll show you another way of addressing this here in a moment, but we'll go with this for the moment. All right, so here I'm going to have my 12 over 4, right? I'm going to have my, well, I say 3 to the 12th over 3 to the 4th. That's going to get me 3 to the 8th. And then this whole piece comes along, right? This dividing by 3 to the 3rd times 1 over 3. So now I've got 3 to the 8th over 3 to the 3rd times 1 over 3. Well, this is going to reduce to 3 to the 5th over 1, right, times 1 over 3. When you go ahead and multiply that out, I get a 3 to the 5th over 3, which is 3 to the 4th. Okay, so if I go ahead and do this, when I'm multiplying, I can go ahead and say it this way. I have 3 to the 12th, and then when I'm multiplying with a negative exponent, I'm going to subtract that exponent. If I wind up dividing by a positive exponent, it's also a subtraction. And again, here I'm multiplying and I have a negative exponent, so I'm going to subtract that. That's going to give me 12 minus 4 is going to give me 8. Minus 3 is 5. Minus 1 is 4. So I've got 3 to the 4th. And this, we can take it directly to this, but you have to keep in mind whether or not you're multiplying or dividing, right? So here I'm multiplying and I have a negative exponent. If you stop and think about what you're doing when you're dividing by some exponent, some number with an exponent on it, that's the same as multiplying by its reciprocal, or making it a fraction. So anyway, that's a little bit of detail in that, but hopefully that makes sense. And I've got one more problem, and then we'll call this good. And I didn't erase it all. So here's the one that I wanted to show you as a trick. So here I have my groupings, right? I'm going to go ahead and deal with that. Here I decided I was going to deal with my denominator first, because this looks like a super duper easy denominator. So 3 to the 1st is a 3, 19 to the 0 is a 1, right? And then I go ahead and deal with my numerator. So when I take a look at this, if I stop and spot this, this is fine. So here I can see that I have a 4 in front of this parens. I have a 4 in front of that 3. And I have a 4 hiding inside that 8, because 2 times 2 times 4 would also give you that same value. It's going to be a 16, right? So I can take that 4 out of everywhere in the numerator and cancel it with the 4 in the denominator. And when I do that, I wind up with a 2 minus a 3 plus a 4, right? Because I have a 2 times 2. And then, so that becomes a 2 minus 3 gets me a negative 1, plus a 4 is going to get me 3. and that is my solution. I am going to go ahead and stop at this point, and hopefully we will have some results as far as looking at the lattice multiplication here shortly.